Good afternoon, everyone. My name is Linda Simonson, and I am the manager of the European sales for Digital Ed. I have helped teachers and universities to success over the last 13 years with the Möbius platform, and I'm excited to welcome you all here today to this webinar, Improving Your Online STEM Courses with the Möbius platform. Before we get started, I would like to inform you how you can participate in today's event. You will have the opportunity to submit text questions to today's presenters by typing your question into the questions pane of the control panel at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. We are also recording this webinar and will send you a link to the recording a few days after this event. It is with great pleasure I would like to introduce you to Dr. Ebba Ossiannilsson. Her knowledge in this area is impressive, and I feel honored that she has accepted to moderate our webinar today. Ebba is a professor and doctor with special focus on open, online, flexible and distance learning and quality enhancement. Her research and interest is also on innovation, digitalization, leadership, and learning spaces in the digital era. She is then the chair and ambassador for the International Council for Open and Distance Education, and she is also the European Distance e-learning network. She runs her own successful consultancy company on innovation for quality. She is the vice president of the Swedish Association for Distance Education and even for the Swedish Organization for E-Competence. She is in addition a member of the ITHU, the IT for Higher Education, and the three latter ones are co-hosting this webinar together with the SALSA, which is the SUNET network for the LMS Canvas users. Over to you, Ebba.
Thank you very much, Linda, and thank you very much for this kind introduction. And most of all, thank you so much for the kind of invitation to invite me to be the moderator for this very, very interesting webinar. I'm very honored and pleased for that. So thanks to you, Linda, and thanks to the Digital Ed. I'm sure we will have a very, very nice and fruitful discussion over the next couple of hours. So we have today three speakers. It is Dr. John Watkins. John recently completed a PhD in theoretical physics at the University of Birmingham in UK. He has a keen interest in educational technology with a focus on the application of computer-based algebra system for creating engaging learning resources. John first worked with the Maple TA and at the University of Birmingham, where he trained a team of staff and interns to write STEM-based questions for development across the College of Engineering and Physical Sciences. Then we have Dr. Tommy Gustafsson. Tommy is a senior lecturer in mathematics at the Department of Mathematical Science at Chalmers University of Technology. Gustafsson's main interests are teaching and education issues and have in recent years focused on different aspects of teacher training, but also on the transition from secondary school to university mathematics. He is also involved in various projects with focus on developing digital competences. Then we have Damiano Ognisanti. He is a lecturer in mathematics at the Department of Mathematical Sciences, University of Gothenburg. He graduated in 2014 with a double master degree in applied mathematics at the University of Gothenburg and Chalmers University of Technology in Sweden.
Okay, so my name is John Watkins. I'm from the University of Birmingham. Just for a bit of context, University of Birmingham is in the centre of the UK. It's one of the largest universities in the UK. And we really are trying to think how we can and use these online education tools to improve learning in all sorts of different ways. So today what I'm going to do is I'm going to show you an overview of the products that we use to do that, and a little bit about how we can use those products. Okay, so I thought I'd start here today. So I've been working with digital ed for quite a long time now. They were previously MapleSoft, and the online education part of MapleSoft has recently turned into a spin-out company called Digital Ed. So people who may be familiar with some of their products may know it as Maple TA. Their product's now been rebranded to be called Möbius now. And so I'll go into a little bit what Möbius is. So Möbius has really two parts to it as far as the product goes. And we have Möbius Assessment. And that is really the part of the tool that is really for assessment. So it has got a lot of powerful STEM engine in there, which is really designed for assessing students. So for things like weekly problem sheets, weekly assessments, or final year exams. Then you have the Möbius courseware part, and the courseware part takes all the bits from assessment, the interactive STEM abilities, and puts that into more of a lesson framework. So students can not only be tested on this content, but they also can use it to learn. And at Birmingham, we use both those parts of the system for various different reasons. And finally, just to mention that along with those two products, you get a large bank of content that's available for you to use. So if you are interested in the product or want to use it, you can get going quite quickly by using existing content. So I just thought I'd go over a little bit of those things today. So very quickly, Möbius Assessment, here's a couple of screenshots from the system. These are the sorts of interactive resources you can create. So these could be resources for learning, but they could also be resources for testing. So all the things you can see on the screen here are different ways the students can interact with the system and be graded on their interactions. So they can be very visual, as you can see in these pictures, or they can be very mathematical, as you can see up here in the equation editor, and anywhere in between. And so really just gives you the ability to assess all sorts of different parts of student competences with these systems. Okay, just to quickly draw back to content, if you go to their website, you can see a nice overview of the content that's available, and I encourage you to explore this after the webinar. If you scroll down, you can go to, let's say, this section, the free content section, and this gives you a list of all, much of the content that's available as sort of curated packages. So you can go in here, choose a particular area, and download a module. So clicking that link would download me a course module, which is a bank of content written by a particular university, in many cases, with questions and assessments built in. So it's worth mentioning that all these, many of these content packages are also available native within the platform. So you can browse to what they call the cloud and select content and pull it into your assignments. So you can get going very quickly. You can also take all that content, modify it yourself to be more tailored towards your course. Maybe that's changing the language, maybe that's changing some of the words that are used within your particular courses, and then you can use that content yourself. So it really is designed to help you get going very quickly. Okay, so that's enough from the website. So the next thing I want to do is show you a little bit about how how the students interact with the system and how they get to the system at Birmingham. So I noticed that there's a lot of people who are interested in Canvas or part of a Canvas user group here. The University of Birmingham was the first university in the UK to sign up for Canvas a few years ago. From my point of view, I really think Canvas is a very good modern web platform. And the drive from Canvas, as far as we can see, it seems to be a good base, a good solid place for organizing your courses, find some really good core functionality for students as part of their learning. But they really also do support an excellent integration policy. So it is very easy to integrate tools for specific subjects into Canvas. So for us, many lecturers at university will use the quizzing tools that are built into Canvas. But for STEM particularly, we want to go to some advanced functionality and really have an easy way to plug in, and Canvas excellently supports that. So all our students log into Canvas, this is where they end up, and they can see their list of courses. And I'm just going to show you the sort of typical journey a student might take. So they might go in here, they might click on a course, and I've got one here. So this is a course actually that all lecturers will go into too. And once they're in their course, they might click the assignments. So look what assignments they have to do. And here is a list of the assignments from the assignments page. So on this page, students can see a list of all their assignments they have to do. Some of these assignments might be built-in assignments like quizzes, and some of them might be taking you to an external tool. So for students at Birmingham, the first thing we do is we get them to warm up and practice in the system. So using a link like this, we get them to click something like this. So by the way, this is still in the Canvas system at the moment. You click the link and it takes you into a page. Now, sometimes that will take you to a page which is where the system is embedded inside Canvas, and sometimes it will launch you out into an external platform. So for this one here today, I've set it up so when I click this button, it will take me out of Canvas into a separate window, and the students can then carry on there. Now, all authentication authority has been handled by Canvas, so I only have to enroll my students in the Canvas course, and all the rest is taken care of by the links. So if I click that button, it takes me straight into Möbius. So it's really, really easy for lecturers to provide links to their students to Möbius resources. And it's really easy for students to find those links. It also has the advantage that the gradebook can be managed in one place within inside the Canvas system, and everybody knows that. But for more advanced features, they can go into the Möbius system and look at the gradebook there. So the integration is very nice and easy. It's worth mentioning that Canvas is not the only platform that you can integrate Möbius into. Möbius supports a lot of different integration methods. The most common nowadays is LTI. So all the major learning management systems support that: Blackboard, Ping Pong, Desire to Learn. There's lots and lots on the list. Okay, so I'm going to now show you a little bit about the student readiness test. The first thing the students might see when they come to the platform. So if I just press this here to resume. This is the first question in the system. It's a very simple question for the students to navigate around, and really is designed to teach them how to move around the system. So the idea is that even though the students have never seen this system before, the system will help you, the students learn how to use it and upskill them. So this question says go to question 5. So I do that. It tells me to find the number on this page, which is this number, 3.14. And then it tells me to go back to question 1 and to enter that number. So as you can see, the students very quickly have learned how to navigate around the system. Once they're happy, they're told to press next, and it carries on like this. The next few questions are all about how to enter things into the system using the mathematical entry. And as you go further, it teaches you about things like when to quit and save, what happens when you press submit, things like that. So I'm just going to very quickly browse through some of these questions so you can see the sorts of things that are there. So different entry modes, how to do multiplications, talks about a symbolic editor, and how to get this free response area for students to use. Okay, we've seen that question before, question 5. And as you can see, it carries on. So it really is a nice soft landing for the students. It's something they can draw back to later if they get stuck, but it's a good place to start. Okay, so that's the student readiness test. For today, after giving a student practice with that sort of thing, the next thing we'll then do is give them some assessments. So let me now show you the sorts of question types you can ask to your students, the sorts of questions you can ask to your students and the way the students can interact with this system. Okay, so to do this, I'm going to log in directly to the platform. So I've landed here now on the home page of the system, and here are a list of my classes. And for today, I'm just going to go into this one. So this is a pre-prepared set of content that shows you some of the features of the system. Okay, so at the bottom, I've got this demo of question types. I'm just going to have to share my change my screen quickly. Okay, perfect. Right, so this is the question types demo. I'm just going to press resume. Okay, so a lot of the things you might expect to be here are here if you've used different quizzing engines, but there's quite a few twists and different ways you can use these things. It's worth mentioning. So this question here, as you can see, is quite a straightforward multiple choice question. But the difference here is that because this is a tool that's really focused around STEM, it has a lot of tools in there to help you build questions like this really optimally. So if you look at this question, you can see there's a question here, and there are 4 answers. One of them is correct, and there's 3 distractors. Now, in this particular case, what's happening is the system will generate a question every time the student comes to this page that's different. The variables will change, the expression will change, but the answers are connected to the question by an algorithm in the back end that can calculate the correct answer and calculate distractors for you. So this is a really nice way to build questions. You can code in the common mistakes that students make and give students endless practice if you want, or you can differentiate them so that you get students get different quizzes in front of them. That's really useful for things like class tests to avoid cheating, but it's also great for practice. So even though this is just a simple multiple choice question, with the power of an algorithm or a language behind it that the system has, you can really do a lot more with it. Okay, so let me move through here. Again, this one is another multiple choice question, but it's a multiple choice question this time where we have graphs. And if you can see these graphs and I hover over them, you'll see the word maple plot appearing. Now, this means that this graph has been generated by Maple. So much like the question before, we have an expression, which is a graph is generated for, and that's the question. And the answers are automatically generated as well using the algorithm in the background. So this again makes it a really nice way to test a different concept. Can students understand the visual representation of these graphs? And so just to finish off that point about multiple choice, many different things can go in these boxes. They can be algorithmic, they can be very visual. So that really just shows you some of the power of just using multiple choice in this system. Okay, the system is built for STEM, so it understands primarily, so it understands units. So in here, you can answer questions like 1 centimeter as an answer, or you can put 0.01 meters, or you can even do things like inches. So let's say you could put 2.54 inches in as an answer, or sorry, 2.54 centimeters in, or whatever you wanted to, sorry. You can put answers in inches and it will convert between. So the system is intelligently able to convert between units. Now, as you can see on the screen, there is no text all over the screen telling the students how to enter those units. And you want to keep it nice and open so the students don't get clues in the questions that are all about syntax or how you enter something. So you'll see up here, there's a little context-sensitive help. So students that get stuck, they can click this and it'll give you examples of how to enter things. So with the number box selected, I get help on numbers. And with the units box selected, I get help on units. As you can see, the system supports all the major units and different used SI units with all the different modifiers in there as well. So students are able to answer questions without you giving them clues how to do it. So it should be able to focus on the content of the question and the learning outcome that you're trying to test. Okay, so many people who come to university when they first come are not that familiar with how to enter things into a computer mathematically. Now, if any of you have used things like Excel before or other programming languages, you'll find that the syntax is very straightforward to you. But that's not the experience of many university students. So if you wanted to answer this question, you might answer it like this by using this sort of syntax. And people will be very comfortable with that syntax if they know it. If they don't, what's the solution? Well, the solution here is allow them to change entry mode. So I'll press this button. And this gives the students a palette which will typeset and lay their mathematics out as they type it in, so they can see what they've typed in is what is in their head. So what I just typed in, I'll just type exactly the same thing again. I could type in 15 times by x to the power of 14, and you can see it typesets automatically. But I've had to know those symbols to do that. So let's say I didn't know some of those things. Let's say I wanted to type in x to the power something. Well, what we have here is a palette that we can choose from. So if I click this, it allows me to put in, it gives me a little template, and I can just find and replace things. So this is a nice model for students to use. And you can chain together the bits that you know with the bits that you don't know. And as you go over time, you can learn as you go through. So this is really to support a hybrid method of learning as you're going, but making sure all the time that what you type in is what the computer and you both understand. This is a nice method. You'll notice at the moment there's not a lot of options on this palette. This is a particular type of palette that's used here, entry box that's used for this type of question. And some of the other question types have more advanced palettes. Okay, so this one's called a Maple graded question type. So Maple is the computer algebra system that powers Möbius. Maple has a huge library of functions in there across all types of mathematics and sciences. And so often you have functions in there to do the work for you. So it's really handy that we have that Maple library there. And also it gives us the power to really be quite clever about how we grade different objects a student might enter. So you could ask a student a question like, give me the answer to a question which the student may have to work out, is that a single number, or is that a matrix, or is it a vector? And that's part of the question. So with this system, as you can see, I have a blank answer box here, and I have the ability to enter anything I want. So if a student has been asked a question, maybe they think the answer is a number, and they can put the number in there. Maybe they think the answer is a matrix, and they can put a matrix in there. So I'm not giving any clues away with the type of answer box towards the type of answer. Now, with this system, it's clever. It doesn't have to grade things exactly as they see them. So a question could be testing properties. So it might be something like, give me a matrix which has a determinant 1. And so there are many, many matrices that could have that property. And so the students can enter any matrix they want in here, which has that property, and the system is able to grade it based on that property. It doesn't have to just check that this thing is equal to this thing. So it's quite advanced. It also supports this answer type, this answer box, different types of questions. So I think about it more like concept questions. So it's very easy to ask a student, what is the answer to this integral? What is harder for students to do is write the integral in the first place. So you might take something like a line and rotate it around an axis and ask the students, what's the equation that you need to solve in order to work out the volume of revolution? So in that case, the student might want to enter something like an integral as the answer, where they may have limits on there. It may have a function in here that you want them to integrate over, and they have to work it out themselves. So this could be the final answer to a question the student has given. So notice the student has not given an answer, they've just formed the integral, and then that is the answer to a question. And I think that really is nice because it tests a different part of the concept that they're not used to being tested on, probably with a computer. Okay, so we're now on computers and we're doing assessment on computers and we're doing learning on computers. So what can we use computers for to increase to get away, to give us extra benefits away from paper? So paper is really good for certain things, and lecturing is really good for certain things. But what we have here is an opportunity to try and see what we can use the computer for to get across other concepts. So with this tool, we're able to plot graphs the students can look at and interact with, and then make a decision about that graph that they may not have been able to make if it was a static position or a static graph. So with this question, they're asked to enter the equation of a graph, or of some sort, and that could be the equation of that surface. And this is something that is really interesting for students because this could form part of an assessment or a weekly problem sheet. It's really trying to get away from the mechanics of just doing things and really about being interested in exploring the STEM content that you have. As you can, yeah, that's fine. Okay, so moving away slightly from some of those more mathematical sort of response areas and inputs, the system supports a lot of very visual things. So you may have seen some of these big things before in other systems, and they're all supported here as well. So here is an example of what they call clickable image. Very, very simple question type, really, but quite powerful to use, especially for learning. So very simple, you upload a picture, and then you draw boxes on which are the correct and incorrect parts of the answer. So here the student has to select a part of the answer that they think is correct. And in this case, I'm going to select that one. So I've seen this used for things like this. I've also seen this used for proofs where people have uploaded their handwritten proof with a couple of mistakes in it. And the students have to find the mistake in the proof by clicking hotspots. I like the fact that you can put these alongside different question types in this system. And the students can, it keeps them active and interested in what they're trying to do or learn. We can then move on to things like sketching. So sketching curves and lines and thinking about asymptotics is a really big part of maths and STEM education in general. So with this sort of platform, we can do things like this, where you might want to plot a line, maybe another line, and try and work out something like this inequality we have here. So then maybe I want to say less than, let's say, for example, and then I could highlight a region, and I'm saying that that is the area that satisfies my inequality or something like that. Now, for the keen eyes in the audience among you, you'll notice that's not quite the right answer. I'll leave that as an exercise to the audience. But you can see this sort of power of this sort of interactivity tool, and they're very easy to build in this system. Okay, so moving into something like STEM, into physics, which is sort of more my area. Forces and resolving forces is quite tricky for students to think about. Often the answer will be completely wrong if they've missed a particular force. So making sure they consider all the forces correctly is important. And with this question type, which is called the free body diagram question type, you, very similar to the clickable image, you upload an image, you put some points on, and you draw your forces as a teacher. And the students have got to try and match their forces to yours. So here you might want to put an arrow on like this. You might want to have gravity on there for that one. You might want to do something like one here and put that as a normal reaction, and carry on and put all the forces you can think of on here. And within tolerances, the system will grade the forces, and the students can understand what they've missed or not missed. Then moving on to sorting. So the sorting question type is quite a generic question type. You can sort all sorts of different things. In here, we're sorting some mathematical expressions. These expressions were probably written using LaTeX or MathML to look nice. There could be pictures in here. There could be some of the plots that you saw before that we could be sorting. Anything you want to do, you can put in these boxes and allow students to sort them in different ways. But what I'm trying to get across today is that this is a system which is primarily optimized for STEM, but it has a lot of adaptive capabilities, a lot of algorithmic programming capabilities that allow you to use these different interactivity objects, that's how I think of them, ways students interact with the system, to make really rich content out of. So a good example of that would be something like this. So this is what's called a math app. So this is an interactive application that allows students to explore integration and a part of a concept about integration. They can change the function, they can change the amount of slices they might have here, and they could be asked a question about the difference between the actual area of the shape and the area of the rectangles. So that gets there, and you can say move this, and you can do that with different functions, look at pathology, things like that. Now this is fully customizable yourself. This particular interface here that I'm drawing a sort of rough circle around, this interface is designed using sort of a WYSIWYG tool, which is the Maple engine, and then they can be played back to students, and students' interactions can be assessed. Now, so these are really nice things to use if you're not a web programmer, but you do want to use some interactive visual things. These are very nice. It's a very nice tool and a very nice way to do that. So these are the sort of things you can create. These are called math apps. Okay, good. So if you are so inclined and you have interests or as such, you can, I've got something there, you can make even more interactive things by using JavaScript and HTML. So here is an example of a JavaScript app that's written. It is an app that's designed to grade your ability to understand the solar system. So one way we could have done this is we could have said, what is the, give me the list, give me the planets in the order they appear in the solar system, starting from the sun. And you can just give a list of planets. Slightly more interesting and more engaging is to do something like this, where you can drag on the planets. And it's asking the same question, but it's doing it in a different way. And you will find that some students perform better with this sort of tool rather than a list of things. And so if you're teaching, really nice, but equally if you're testing, it could be also good, because this is a much more real world way of thinking about these things. So at Birmingham, we use a lot of we have a big project every summer that writes content like this, written by undergraduate students for other undergraduate students. And this is a really fun thing for the students to do. So there's a lot of energy around Birmingham over the summer, building these sorts of apps and hosting them in Möbius. Okay, good. Now, I mentioned briefly earlier that Möbius has got some adaptive capabilities. And so one of the big criticisms of online platforms is that you cannot test things like the student's ability to the steps in their work solution, or it's hard to differentiate between good and bad students sometimes, so giving different content. And if you think about an exam, for example, when you give an exam, the exam is what it is. And if a student makes a mistake and goes down a wrong path, you can't do anything in the exam. And so maybe you were asking them about one concept, but they got confused and started going some other direction. Then it becomes quite hard to work out how to give them grades. So with this platform, we have a lot of adaptive capabilities. So we can keep focusing on a particular area if we want to, or we can try and drill down and find where students are weak. So here's quite a straightforward example of a question like this, built in the adaptive framework. So the question is saying, what is the 13th term of a sequence? So you can see I've got 2, 5, 8, 11, and it goes all the way up. And the student's supposed to work out what the 13th term is. So what I'm going to do is go through as a slightly weaker student who maybe makes a mistake and see how the system behaves. So what I'm going to do to answer this question is I'm just going to do 13 times 3 and put the answer in as 39. That's maybe what this student does. Misunderstood the question, misunderstood the concept, they got the answer wrong. So, okay, so now the question has been marked as wrong. And now the student has been given an opportunity to try and find where their weakness was. So it says here, identify the common difference. So here, the common difference is a phrase that people might not understand, but in this case, I can see the word difference, and that means 3. So good, it's told me that I'm correct, so that's not where I'm weak as a student. Well, the next thing it's telling me to do is enter an expression for the 13th term of the sequence. So I did 3 times n in this here. I'm going to press verify. And so that tells me I'm wrong there. So as a student straight away now, I've seen that's where my error is. Maybe that makes me pause and think and go and try to work out where I was wrong. Maybe it makes me go and ask my lecturer, why am I wrong here? And then they can have a discussion around that. But for here, I'm going to carry on, see if the student has the ability to take that knowledge and then use that to get the answer right. So in this case, I should have given the answer as 38, based on what it says there. And you can see now the thing marks me correct. Okay, so what does this do? So it has a few effects. So first of all, if I was a student who knew the answer straight away, I could give it the answer 38 and then move on to the next question. There's no point in slowing that student down if they can do it correctly. It also means that I have not given the game away for students that know the answer, so I should really reward them with a higher grade. So if I get it right first time, I'm going to give that student 1 mark. Now, a student who got it wrong the first time has to go for a different route. In this case, I'm going to cap their mark at 3/4 of a mark. So a quarter for each section that follows. So the route, if I got everything right going through this route, with the extra help, I can only have got 3/4 of a mark, 75%. And in this case, this student got half marks, so 50%. So that's 2 benefits there. And finally, about catching errors, the student has found out where their weakness is very quickly. They found out when they need to know, which is now, not in 2 weeks or a week time after their work's been marked. They found out when they've made a mistake, when it's fresh in their mind, when they're interested in trying to work out how to correct that mistake. And also the lecturer has found out where the mistakes are in his class by looking at, do people get this part wrong, or this part wrong, or this part wrong? What are people doing wrong? And so maybe next lecture you come to, you give some extra material around this particular point if a majority of your class are making mistakes like this. This is called the adaptive framework. And it's one of the levels of adaptive ability in Möbius that you can use. And it doesn't have to be numbers in these boxes. They can be any of the things you've seen so far today. Multiple choice questions, math boxes, interactive apps, anything like that can form a response area, a place for the student to interact with the system and be graded on. Another example of adaptive question in something like a more different mathematical domain. This is asking you for the minimum of a function, and I'm going to try and get the answer wrong here. I got the answer wrong once, and the system's now giving me a second chance to have a go again. So that's the sort of thing you can do. Take another guess. And in this case, it's now gone, okay, clearly you don't know the answer. I'm going to adapt and do the same thing. So again, it can be used in all sorts of different ways. You can see how this can be a very useful feature. Now, sometimes we really need humans to look at what other humans are doing to assess how they're doing with different types of work. And so we do a lot of this at Birmingham. So we do a lot of work where the computer will grade things, and students might also provide their work solutions, the actual sort of rough working in the system as well. And the way we use that is we will ask the student a question in Möbius. If they get the answer correct, it's fine. If the answer is incorrect, we might get PhD students to review their work solutions and see if we can award any partial marks. And sometimes we use the question that way. There are some question types, I think, particularly around proofs in mathematics, but really is a very human endeavor to work out whether you've understood the proof. So we might do an assessment with some automatic assessment and some human assessment built into it as well. So to do that, sometimes we use the essay question type. So this is just a response area like this, where you can type into the box, and you can also put mathematics in there. So you have the ability to enter it in using the palette that was there before, or even using LaTeX, if you're familiar with LaTeX. So for the people who are, just as an example, you and your students can both type LaTeX into the system in this sort of fashion, and it will typeset for you like that. So depending on which one you're more comfortable with, you can type LaTeX, you can use the equation editor, and the students can now talk to you in the mathematical language they're comfortable with, and you can give them partial grades for that. Sometimes you feel it's quicker for students to do something on paper. So alongside the essay question, we use the file upload question. So in this case, it would be a case of students do your work on paper, you take photo of that work and you upload it. We might do that for weekly problem sheets, but we might also do it for things like chemistry labs, where you might have to produce a spectrum from your from instruments, label the spectrum, and upload it to be looked at to see if you graded that correctly. The instructor decides whether you've correctly identified the particular peaks or you've done the experiment correctly in the first place. So having this kind of semi-automatic model, we find is really, really nice for some subjects that we use at Birmingham. Okay, so at the end of your assignment, I'm just going to show you a little bit of that now. What happens? So if a student presses submit, you get a summary here. And the summary says, here's a question you've missed, go back. And the students have the opportunity to go back and review things they've missed before they carry on. If they're happy they've finished everything, they press submit again. And depending on how you set up this assignment, you might get some feedback at the end. So you might get some feedback which says, here's your score. It might say you passed. It might say thank you for your submission, and it will be reviewed, and your grade will appear in Canvas shortly. You have full control over what feedback is given to the students as they go through the assessment and after the assessment. In this particular one, it's been set up so they can view the details straight away. And the details are essentially like a marked answer script. So you have the student's answer and what the correct answer should have been, and any feedback that's automatically generated underneath. So you can have a question which has got certain variables in that are specific to that student, but the feedback can be tailored around those variables. So you can see a work solution that works those numbers specific to that student right through that work solution. This is the sort of thing you'll see. Okay, so at any time, this is available to students, so they can go back to their gradebook at any time and review that content. Right then, I'm going to share this again. Okay, so what I've shown you so far is a few of the different types of response areas in the system. So you could take all those different things and make an assignment out of it, or an assessment. So that's the sort of thing you might see every week, an assessment that comes through every week. And those sort of assessments will be sort of linear. So they might have 10 questions in. The students will answer that question, press submit, and they're done. They'll get a grade. And the next week they might get another one. That's kind of an assessment. But more and more now at Birmingham, we're using Möbius for teaching as well. So there are a few courses at Birmingham where we start to do more of a flipped model or blended model, where we're giving the students lesson material or sort of problem sheet material in more of a lesson form. So you can take the same objects that I'm showing you and turn them into a lesson, where a student is not really graded on getting it right or not. It's really laying out the content so people can learn. So here I have one called sample lesson. I want to go in and show you. Okay, so hopefully you can see my screen now. It's worth just mentioning briefly, at the start of each learning object or assessment object, you see a screen of policies which shows you, basically shows the students what they're getting into. So the time limits, things like that. So this is the screen you see here. Okay, so if I push the zoom, I go back into this lesson. So at the left-hand side, you can see what looks like an index of the different objects in this lesson. These are kind of like pages in a book or chapters in a book. So as I scroll down, you can see equation of a line, series expansion, the solar system. So there's no connectivity here. I've just got some random examples. And I'm just going to show you about those right now. So at the top, I've got equation of a line selected. Now if I just scroll down this page, you should be able to see that laid out on this page are a few different types of answer boxes. So these ones have been laid out in a table. We've got these ones, this is the true or false on the line there. And here we're using this box here for looking at the equation of a line. So the questions can be embedded throughout content where the questions are most appropriate. And the way I think about it is you normally teach a student something and want to check they've understood something. So to do that, we ask them a question and put that question box right in the content where it needs to be. So let me have a look what happens. So here we have an equation of a line. And I'm being asked to, maybe I've been taught a little about it in the previous page, and right now I'm going to be asked a question about it. So let me have a go. So to do this one, I'll try and do this on the fly as I'm going through. So I think the first answer here is -12. And if I can do this correctly, we'll have to see. And let's do, and then, okay, so let's see how do I do. Okay, so I almost got that all correct. Clearly adding is quite hard. So as you can see, I've been told the correct answer and I've got this one wrong. So in this case, it's probably that I've made just a simple error in my adding at the end. But maybe the students check that. So if I want to, I can press this. I've got a bit of feedback here saying it should increase by 9 every time. Yeah, I can see I did wrong there. So what I probably should do is press try another. And you can see the system regenerates another question for me of the same type. And I can have a go again. So that's something I like to encourage the students to do. Have a go at a question, check it, you weren't lucky the first time, and then press try another until you're satisfied that you've got that concept. So that's kind of the model of that. Moving down the page, I can see I've got this true or false answer box here. I'm just going to press true for now, press how did I do, and the system tells me I'm wrong, so maybe I have another go. Obviously, hopefully the answer is false, but the algorithm could be the case so that sometimes they're true, sometimes they're false. And again, pressing try another generates another question. And then you can use an answer box like this at the bottom. So this one here has got an infinite amount of answers, and you could use this sort of answer box in a lecture. So I think this is quite fun. You say in a lecture to people, have a go at this question as a class and see what, shout out some answers to me. So I have to give an equation of a line that passes through the point 510. So this could be something like 510, and that will give me the correct answer. I could also be something like x equals, 5. It could also be something like y equals 3x. And there are many, many different answers you can think of for this problem. So this is a very nice answer box to have for learning. And it's also good for the assessment because as long as the student understands the question, they should be able to put the correct answer in there, and the system will understand that this answer is correct. Okay, so how might you lay out some of this content for learning? So here is an example for Taylor series. It's a fairly common concept that gets introduced to university students. And it probably starts very similar to this. So if you read this in a textbook, it might look something like this. Introduce the Taylor series, maybe give them a graph of the Taylor series. But the difference is here we have interactivity because they're on the web. So let's let students explore a concept rather than giving them one particular viewpoint on that concept. So here I'm asked to explore the graph above and answer a question. So it's saying, look at the point pi over 2, which is here, and it's asking the difference between this line and this point. And as I move this bar here, as with the Taylor series of those that understand it, you can see that this line gets closer and closer to the approximation, and the error gets smaller and smaller. And that's the concept I want the students to understand. I want them to understand that not only the Taylor series is good here, but it also how it is affected at different points down the line. So the student can then look at this and be asked, given the question, maybe they get the answer wrong. The system will tell them they're wrong, and they get a chance to look at the feedback and have another go at the question and get the answer right. Once they have green ticks and the answer is all correct, they're encouraged to then move on. So a good starting point for this sort of material is you take your existing lecture notes, you put them into the system, you can copy and paste, in many cases, straight into the system, and you go through, and where you stated something, you more ask for something to the students. So rather than saying, here's the forces on a block down a hill, you ask them what are the forces. And if they get it wrong, you can tell them the answer anyway, but it allows them to do more active thinking rather than just passively sitting there trying to listen to you. And just like with the previous example, where you might have something like a flat book about solar systems, you see a difference that how that content can come to life when you put something interactive in there. And that really is a great way to engage students. Learning can be interesting. Learning can be hard, but interesting at the same time. And that's really the sweet spot for learning. And that's what we're trying to aim at here. Okay. Now, there was a couple of other features I want to share with you about this system. The first one I'm going to share to you is something I saw a few years ago in this system, and it was based on a bit of research that was done, I think, by MIT. And this is that there was a big movement for everybody to take their lecture materials and put them online, little bite-sized 10-minute, 15-minute sort of concepts, because the theory was that the students would only be able to keep attention for that amount of time. Now, unfortunately, what the research showed about people consuming content through video is that they are no more active than they are when they're watching TV. And unfortunately, the correlation there is also there for the lectures. So lectures the students are not very active in either. So what we really want to do is give students material, but make sure they're interactive and they're actively learning and thinking about the content as they go through. Let me show you what that looks like in this system. What we have here is what looks like a video. I'm just going to play this for you. Now, this video could have an audio track over it. In fact, I have ones later that do. And it looks like a video. A lecturer could be talking, explaining this. But at some point, the video pauses and asks you a question. So in this case, it's asking you a question that's true or false. And the student can answer true or false. And if you notice at the bottom, it says, how did I do? So the student can press that, and then the system will give them feedback. Once the student's happy, they can move on. They've got that concept. They can press continue. And so if we watch it a little bit more, we'll see another answer box comes up. And this time it's an answer box which has numbers and units in there, so which we saw earlier. So you could put 1 centimeter in. So I hope what you can see is that any of the answer boxes that I've showed you today, the interactive boxes, the videos, the apps, all those things can be put into this sort of video framework, and students can be asked questions as they're watching a video. This is quite nice. So essentially, you build yourself a lecture, you record your audio, you embed questions throughout, and now you have an interactive video where the students are interacting and being actively engaged with the learning as they're going through. And I really like this model and this framework. This works on mobile phones, on tablets. It's a really nice way for students to learn. Okay, so let me show you more of a real world example of this. So here's what a real world example might look like. So this is, I don't know if you're going to hear the audio, so I've paused it. This is somebody talking about this particular concept. And as he's talking, there are objects coming up on the screen describing the content and going through. I'm just going to scrub through here, and you can see the content come up as you go through. And he is talking, at least on my end. Then we get into some graphs which come up. And right at the end, the students get an opportunity then to have a go themselves. And so the system will pause, it will generate a question for them, like this, and the students can have a go at the question and see how they do. And I did particularly badly there, which is good because I was guessing. And if we do try another, which I think is what we do, the system will then regenerate another question for you of the same type. So the students are encouraged to stay here, have a go back to the video if they're not sure, ask a lecturer if they're not sure, but this is a really nice thing. So should you move on with a concept if you haven't understood it, the only way to know is to be tested on it and then move on. And then a few weeks later, you draw it back and you ask them some more assessment questions, and that really does support their learning really nicely. Now, many people, when they first come to watch a video is a good format, as is a lecture, but after that, after you've seen it for the first time, it would be useful then to be able to see that and get to that content quickly. So if you want to do that, you can press this button up here and it will lay out the slides with the transcripts on for you like this, so you can draw back to that content easily and quickly later. So that supports both types of learning there. Okay, so just to finish up today, I'm just going to show you a few fun examples of the sorts of things you can do. So this is by far and away the most powerful system for creating rich content for STEM that is out there. You can do a huge range of things with it. There's a lot of built-in things, and there's a lot of flexibility for people with interest to do really exciting things. So this is a 360 video that was created, image that was created, where students have to diagnose a particular condition from these dentures. And the students have to work out whether it's what the conditions are. And press how do I do? Oh, I did well there. So that's one example. And then another example would be we're on the web, there are some really great tools already out there. And with this platform, you really should be thinking about how you can use those tools to support your learning. So here we've embedded a system called PhET into the platform. And with this system, you can build circuits with batteries and wires like this. I want to stress though, this is not something that's native to Möbius. Möbius just makes it very easy for you to plug in content in the system. And here you can ask your students a question like, what is the voltage drop across this, across the bulb? And you can have connected questions at the bottom where they have to answer. So that kind of gives you a really sort of a huge range of things you can do. There's lots of built-in stuff. There's lots of adaptive stuff. There's lots of very visual stuff. You can plug stuff in if you find nice tools on the web, and you have a whole range of things you can do. And to get going, there's a huge content library for you, and a really large community. So if you need help, there's helps out there. So we've had a lot of success in Birmingham using this. We've scaled it up from being used just at Birmingham to being used at our remote sites in China, in Dubai, and it's used across all aspects of STEM education at Birmingham. So I think that's everything I want to share with you today. And I think I'm going to pass it over to the next presenter. If there are any questions for me, then feel free to throw them into the question answers and we'll answer them at the end of the session. Thank you.
So thank you so much, John, for walking us through the system and everything what you can do with it and how to improve your courses with Möbius and to improve student success, I will say. And thanks so much for sharing your knowledge and experiences. Very, very good. I'm sure there will be some questions maybe later on, but not for the moment. So please, if you have any questions for all the presenters, please raise them. There is either the chat box or there is this Q&A in the bottom of the screen. You can raise questions. And also there have been some smaller questions during your presentation, John. And one I will pass over to the next presenters because it's belong to them. And also there has been a question about how many participants there are. There's also on the bottom of the screen, you can click on the participants and then you can see all who are attending our webinar. And if you like, you can also feel free to chat with them in between if you know some of the persons. So please feel free to do that. I know that we have people from very, very many countries, from Europe, from Sweden, Denmark, Netherlands, among others, Austria. I know we have people from India, we have people from Canada, we have people from Turkey. So it is very wide and broad participants audience we have today. That is very, very nice. So there was a question from Birger Eriksson, and he asked, are there a Swedish language pack with our comma separation? And I will pass that one over to the theme from Gothenburg. It is Tommy and Damiano.
Hello.
Next.
Should we answer that question now or should we wait till afterwards?
It depends how you think it will belong to your presentation. But
No,
maybe,
it doesn't. We will answer it later.
You have an answer on it right now.
Yeah, I mean, we use the dot as a comma separator. We don't use the comma symbol. We use the comma symbol and semicolon as separation of answers. And I don't think you can change which comma separator you use, but we write it in the question that you have to think about these things. It's very clear for the students.
Can I answer that as well? So yes, you can use comma separation for numbers. If you look at the number box, it does support 1,000 separators as commas, but also the other way around as commas and dot the other way around. So commas for decimal points for 1,000 separators. That's particularly on the numeric question type, which you can use that. But as Damiano says, often people will use the full stop for decimals because it's more standard SI sort of a framework. So it's up to you. We see that used typically more in schools, the comma separation, and then people transition to the full stop as they go to a university.